Hi, I'm Ron. Welcome to Math Antics. In our video about basic linear functions, we learned that the equation y equals mx plus b can be used to represent any linear function on the 2D coordinate plane. In this video, we're going to dive a little deeper and learn two new equations, one for calculating the slope of any line, and the other for calculating the distance between any 2 points on a line. To do that, the first thing we need is 2 points. Actually, I meant 2 points on the coordinate plane, but nice shot anyway. We're going to name these points point 1 and point 2. As you know from geometry, a line can be defined by any 2 points. All you need to do is connect the dots to get a line segment. And you can get the infinite line by extending that line segment in either direction. Our goal in this video is to learn how to find the slope of a line segment like this and to calculate the distance between its 2 endpoints. The key to accomplishing those goals is to realize that you can use any line segment to make a right triangle. To do that, start from the point that is the highest on the coordinate plane and draw a vertical line straight down towards the bottom of the coordinate plane. Next, move to the other point and draw a horizontal line until it intersects the vertical line you just drew. See? Now you have a right triangle. The vertical and horizontal sides of the right triangle are perpendicular to each other, so they form a right angle. And the original diagonal line segment is now the hypotenuse of the new triangle. Temporarily, we're going to call the horizontal side of the triangle change in x and the vertical side change in y, which are awkwardly long names, but that's exactly what the two sides represent. Imagine starting at point 1 and then slowly moving along our line segment towards point 2. As you do that, the x and y coordinates that you're located at are changing, right? Your x coordinate is changing because you're traveling to the right, and your y coordinate is changing because you're traveling up. And when you finally get to point 2, the total change in your x coordinate would be the length of the horizontal side of the triangle, and the total change in your y coordinate would be the length of the vertical side of the triangle. That's cool, but the names change in x and change in y are kind of long. Fortunately, mathematicians have a shorter way of saying the same thing. They use the Greek letter delta as an abbreviation for the words change in. That means you can just write or say delta x to mean the change in x, and delta y to mean the change in y. Okay, now that we know what those sides represent and we've got nice names for them, how do we actually calculate the lengths of those sides? To do that, we just need the coordinates of the 2 points that form our line. Since we named them point 1 and point 2, it makes sense for us to call their coordinate values x1 and y1 for point 1, and x2 and y2 for point 2. We write the 1s and 2s as subscripts after the variables so we don't mistakenly think it means x times 1 or x times 2. The subscript numbers are simply a way of distinguishing the different variables in the problem so we can keep track of which is which. Anyway, to calculate the delta x, you need to find the difference between the x coordinates of the 2 points. In other words, you need to subtract the x value of the first point from the x value of the second point. So delta x equals x2 minus x1. Likewise, to calculate delta y, you need to find the difference between the y coordinates of the 2 points. So delta y equals y2 minus y1. These simple equations for finding delta x and delta y are important because they're used in the equations for slope and distance, which is what I want to show you now. The equation for the slope of a line looks like this. Slope equals delta y over delta x. Remember that the fraction line means division. So delta y over delta x is the same as delta y divided by delta x. You might also see the slope equation written in expanded form like this. The only difference is that the delta x and delta y have been written out to show the subtractions you need to do to get those values from the coordinates. Either way you want to write it is fine. And some of you may have heard this same equation expressed using different terminology. Have you ever heard someone say that slope equals rise over run? Rise and run are just different names that are sometimes used to describe the change in y and the change in x. The idea is that if you were to run along the line in the x direction, you would rise by a certain amount while you did that. Or would you? What if the line has a negative slope, which means that as you move in the positive x direction, the y value decreases instead of increases? That would be like going downhill instead of uphill. And the word rise seems less fitting in that case. Because of that, we'll just use delta y over delta x in this video. But it's certainly not wrong to use the terms rise and run, especially if it helps you remember the formula. But if you do, just remember that the rise can also be negative. Now that you've seen the equation for slope, let's see the equation for calculating the distance between 2 points on the line. Distance equals the square root of delta x squared plus delta y squared. Does this equation remind you of anything you may have seen before? It certainly reminds me of something I've seen before. You stole my theorem. Hi there, Pythagoras. I didn't steal your theorem. I'm just borrowing it so I can calculate some stuff. Don't worry, I'll give you credit for it. Oh, well, I guess as long as you give me credit. Do you remember how the Pythagorean theorem tells us the relationship between the three sides of any right triangle? That means that if you know the lengths of two of the sides, you can calculate the length of the third side. Well, we just saw that if you turn a line segment into a right triangle, you can calculate the lengths of two sides, which would be delta x and delta y, right? So we can just plug those values into the Pythagorean theorem. You're used to seeing that theorem in this form. A squared plus b squared equals c squared. Since a and b are the lengths of the horizontal and vertical sides, we can plug in delta x and delta y instead. And instead of c squared for the hypotenuse side, let's use d squared because the length of the hypotenuse equals the distance between our 2 points. To solve for d, or distance, we take the square root of both sides and we get d equals the square root of delta x squared plus delta y squared. This special form of the Pythagorean theorem is usually called the distance formula in algebra because you can use it to find the distance between any 2 points on the coordinate plane. And just like with the slope equation, you'll often see it in expanded form where the delta x and delta y are written out as the subtractions x2 minus x1 and y2 minus y1. All right, now that we have our equations for slope and distance, let's see them in action. Suppose we're given 2 coordinates and we're asked to find the slope of the line they form and the distance between those points on the coordinate plane. The first thing we need to do is name the coordinates since they aren't named already. And even though it's not really necessary, if you're like me, you might want to draw a little sketch of the problem to help you visualize what's going on. The equations for slope and distance both use delta x and delta y. So let's calculate those values first. Delta x equals x2 minus x1. And in this problem, x2 equals 4 and x1 equals -2. So delta x equals 4 minus -2, which is just 6. Next, we calculate delta y. Delta y equals y2 minus y1. And in this problem, y2 equals 3 and y1 equals 0. That means delta y equals 3 minus 0, which is just 3. Great. Now we have our delta x and delta y values, and you can confirm that we got them correct by looking at our graph. The length of the delta x side is 6 units, and the length of the delta y side is 3 units. Now let's plug those delta values into the equations for slope and distance. Slope equals delta y over delta x. We just found that delta y equals 3 and delta x equals 6. So our slope equals 3 over 6, which simplifies to 1/2 or 0.5. That was easy. Now let's plug those deltas into our distance equation to see how far apart those points are. Doing that tells us that the distance equals the square root of 6 squared plus 3 squared. 6 squared equals 36. 3 squared equals 9. 36 plus 9 equals 45. So the distance between the points would be the square root of 45. You could also simplify the answer to 3 root 5 or use a calculator to convert it to a decimal, which would be 6.708 rounded to 3 places. That wasn't so bad, was it? But let's try one more example to make sure you've got it. Again, we're given 2 points, but this time they're already shown on the coordinate plane for us. We'll label this one that's furthest to the left, point 1, and the other one, point 2. That means this point's coordinates will be x1 and y1, and this point's coordinates will be x2 and y2. First, we plug those coordinate values into the delta equations. Delta x equals x2 minus x1, which is 1 minus -3. So delta x equals 4. Delta y equals y2 minus y1, which is -2 minus 5. So delta y equals -7. again, we see that those delta values agree with the graph and the right triangle formed by the line between the 2 points. Or do they? One of our deltas is negative, but a length can't be negative, can it? Well, no, but remember that deltas are really a difference between coordinate values, so they can be negative. The lengths of the triangle sides are really the absolute values of the deltas. But the signs of the deltas are important because they help us get the correct slope, since a slope can be positive or negative. Now that we have the deltas, let's plug them into our equation for slope. Slope equals delta y over delta x, which would be -7/4. We could just leave the slope like that as an improper fraction, but we could also convert it into mixed number form or get the decimal value with the calculator, which is -1.75. Now that we found the slope, let's find the distance between the points by plugging the deltas we already calculated into that equation. That gives us distance equals the square root of 4 squared plus -7 squared. 4 squared equals 16, and -7 squared equals 49. That means the distance is the square root of 16 plus 49, or the square root of 65. That root can't be simplified, but we can use a calculator to convert it to a decimal if we want to, giving us a distance of 8.062 rounded to 3 decimal places. All right, so now you know how to calculate the slope of a line if you know any 2 points along that line. You also know how to calculate the distance between any 2 points on a line using the so-called distance formula, also known as the Pythagorean theorem, invented by me, Pythagoras. Yes, thank you for reminding us, Pythagoras. Remember, the key to success in math is to practice, so be sure to try some slope and distance problems on your own. As always, thanks for watching Math Antics, and I'll see you next time. Learn more at mathantics.com.
السلام عليكم.
وعليكم السلام.
طبعا هو كان الفيديو الأولاني دوت بيتكلم على analytic geometry وهو الراجل شرحها. أنا قلت لكم إن أنا بالنسبة لي يعني بفضل الراجل ده لحد كبير في يعني في الطريقة بتاعته في الشغل حتى. نشوف كمان فيديو صغير كده عن السيركل اللي احنا اتكلمنا فيها وبعد كده نكمل شغل عن السيركل.
Circumferences of the circles.
كده الصورة ظاهرة عندكم ولا لا الأول؟
ماشي
تمام؟
تمام.
Hi, welcome to Math Antics. We've learned a lot about geometry so far, but there's one really important geometric shape that we still need to cover, and that shape is a circle. Since the invention of the wheel, circles have been extremely important to all humanity. Grog the wheel. Thanks, Grog. In fact, you probably see circles almost everywhere you turn. But mathematically, what is a circle? Well, in geometry, a circle is defined as the set of all points that are equidistant or the same distance from another single point. And the best way to understand what that means is to see it in action. So here's a single point to start with. And now let's start drawing points that are equidistant from it. This point is a foot away to the right. Now let's make another point a foot away, but in another direction. Let's say up here. Now let's make another one also a foot away, but in another direction, right here. Now let's make another right here.
And another, and another, and another, and another.
Phew, I'm getting tired. But do you see what's happening? The more equidistant points we add, the more the pattern looks like a circle. And that's why a circle is defined as a set of points that are equidistant from a center point. But of course, we usually don't see it as a set of points because there's infinitely many of them. So they form a continuous circle. Okay, now let's learn about the parts that make up a circle. First of all, we have the original point that we started with. That's called the center or the origin of the circle. Next, we have the distance that we use to draw all of the equidistant points that form a circle. That distance is called the radius. The radius is important because it's the distance from the center of a circle to any other point on the perimeter of that circle. And even though a circle only has one radius dimension, you can draw as many radius lines as you want to. Usually you'll only see one radius line drawn since it's the same length no matter where you draw it. Another important circle dimension is called the diameter. The diameter is the distance across a circle. If you start at one point on the circle and then draw a line straight through the center to the other side, that distance is the diameter. As you can see, the diameter is really just the same as two radius lines drawn in exactly opposite directions. So for any circle, the diameter is always exactly twice as long as the radius. All of the equidistant points we drew combine to form the perimeter of the circle. Remember that perimeter is just the distance all the way around a shape. But because a circle is a special shape, the perimeter of a circle gets a special name. It's called the circumference. The circumference is the distance all the way around a circle. We're going to learn how to calculate the circumference of any circle in the next video. We'll also learn how to calculate the area of any circle. But before we can learn those things, we first need to learn about pi. Grog made pi. Sorry, Grog, not that kind of pi. In math, the word pi, which is spelled pi, refers to a very special number. In fact, it's so special that it gets its own symbol. This Greek letter here is the symbol for the number pi. But if pi is just a number, why don't we write it like that? Why do we need to use a special symbol for it? It's a good question, and I'll get to that in just a minute. But first, let's learn what pi really is by seeing how it relates to a circle. It turns out that pi is really a ratio. Now, if you're not sure what a ratio is, you can watch our video about it. But basically, a ratio is just a relationship between two numbers that's written like a fraction. Pi is the ratio of two different distances on a circle. It's the ratio of the distance around a circle to the distance across a circle. And what do we call those two distances? Yep, the circumference and the diameter. So pi is the relationship of the circumference to the diameter. And as you'll see in a minute, because pi is a ratio, it's the same number for any circle, no matter how big or small. Okay, but what number is it? What's the value of pi? Well, to figure that out, have a look at these two circles, one big and one small. We're going to imagine that our circle's diameters are flexible like a piece of string, and that we can wrap them around the outside edges, circumferences of the circles. So for each circle, if we start at the top and wrap the diameter around the circumference, we see that one diameter is not enough to go all the way around. So let's get another diameter and keep going where the first diameter stopped. Two diameters still isn't enough to go all the way around. It looks like we're going to need to get a third diameter and keep going. Oh, so close. 3 diameters is almost enough, but it looks like we're going to need just a little bit more to form a full circumference. That little bit more turns out to be about 0.14 diameters. That means that it takes 3.14 diameters to equal 1 circumference for any circle, big or small. So the value of pi is always 3.14. Well, okay, pi is a little more complicated than that. 3.14 is really just pi rounded off to 2 decimal places. And we actually have to round pi off because it's a type of number that's called irrational. An irrational number has decimal digits that never end and never repeat. Wrong, confused. Yes, irrational numbers are confusing, but seeing some more of pi's decimal digits will help you understand what I mean. To be more precise, pi is 3.14159235897932338, and the decimal digits just keep on going forever without repeating. Pretty amazing, huh? But the good news is that saying pi is 3.14 is usually close enough for most math problems. So that's all you really need to memorize. And that's why we use a symbol for pi in equations. We could write pi with just 2 decimal places, or we could write it with 5 decimal places to be more accurate. Or we could write it with hundreds of decimal places to be super accurate. Or we could just use the symbol to represent the true value, which is infinitely accurate. Okay, so in this video, we learned what a circle is, and we've learned about the important parts of the circle: the center, the radius, the diameter, and the circumference. We've also learned about a very special number called pi. Pi is the ratio of a circle's circumference to its diameter, and its value is about 3.14 no matter what size the circle is. In our next video about circles, we're going to learn how we can use the number pi to find the circumference and the area of any circle. And even though there's not much math you can actually practice in this section, don't worry. There'll be lots of practice problems in the next section to make up for it. Thanks for watching Mathantics, and I'll see you next time. Rob, good at math. Learn more at mathantics.com.
Grammarly is your personal writing assistant for clear emails, confident messages, stronger essays, and more. Because sometimes the kitchen table is the office and the classroom. Grammarly offers suggestions to help you get work done from anywhere. It covers everything from correcting grammatical errors to rewording a phrase for an easier read, so you and your kids can learn to be better writers every time you type. Use it on your computer or phone for a stronger, more confident delivery wherever you live.
Hi, welcome to
السلام عليكم.
عليكم السلام ورحمة الله وبركاته.
على فكرة أنا أول مرة أشوف له فيديو مترجم بالمناسبة. الفيديو اللي فات ده كان مترجم، اللي قبله ما كانش مترجم صح؟
أنا كمان أول مرة أشوف الفيديو ليه مترجم. ده معناه إن هو بدأ ينتشر ولا إزاي؟
لا مش عارف معناه إيه بصراحة. أنا شغلت الفيديو لقيته مترجم، معرفش أنا جبته منين. ما علينا. الشغل اللي فات واللي هو حتى الراجل اتكلم فيه دوت هو الحاجات الأساسية، وده اللي هو في جريد 5 واللي إحنا اتكلمنا فيه من شوية. أنا بتكلم على السيركل يعني. طبعا هنا بقى في شوية تولز كده في الجزئية دي. بتقول لي مثلا هنا بيقول لي ده ستريت. الصفحة متشارة عند حضراتكم كده ظاهرة صح؟ ده ستريت لاين دي مش كده؟
أيوه
تمام. بيقول لي the straight line passing through the center of the circle and the midpoint of any chord of it is perpendicular to the chord. ده معناه ايه؟ بيقول لك if we have circle like that and we have chord برضو زي كده، وبعدين انا معايا point هنا كده دي the center of the circle، ومعانا straight line passing through the center. straight line كده بس. تمام. اللي هو بقى بيقولوا ايه؟ بيقول لي لو ال straight line دوت passing through the center and the midpoint of any chord. هنا مثلا AB ده اسمه chord، وال straight line اللي هو معدي من السنتر ده معدي كمان من الميد بوينت للكورد. يعني مثلا هنا E if E is midpoint of AB and the straight line passing through the center and the midpoint of chord هيعمل ايه؟ يقول لي perpendicular to this chord. perpendicular يعني الانجل دي كده تكون ب 90. يبقى انا معايا، خدوا بال حضراتكم كده، هتلاقي معاك 3 كلمات برضو اللي هي passing through the center، passing through the center، وميد بوينت، midpoint of chord، ويبقى perpendicular to chord. لو طبق 2 هتبقى الثالثه موجوده. فمثلا في اللي هو قاله ده هنا قال لي passing through the center وميد بوينت هيكون perpendicular. طب نمبر 2 دي بيقول لي the straight line passing through the center اللي هو طبق اول واحد passing through the center and perpendicular to the chord. perpendicular اللي هو ثالث واحد. ماله بقى؟ بيقول لي bisects this chord. what the meaning of the word bisect؟
ينصف.
ينصف.
الوضع.
يبقى هو لو الرسمة أصلا كانت كده، الرسمة كانت كده، هو كده straight line passing through the center و perpendicular، هيعمل bisect the chord. bisect the chord يعني معنى كده إن EB تبقى equals EA. طب تالت واحدة بيقول لي perpendicular bisector. perpendicular bisector يعني مبدئيا كده E هتبقى mid point ودي 90 وميجر اوف انجل E 90 of any chord. perpendicular bisector لو ترجمتها حرفي هيبقى العمودي المنصف. العمودي المنصف. perpendicular bisector to any chord of the circle ماله بقى؟ هيبقى passing through the center. هيعدي من ايه؟ من السنتر. طيب ايه المعلومة اللي بعد كده؟ بيقول لي the axis of symmetry of any chord. axis of symmetry of any chord. الكورد ده عبارة عن line segment. والاكس of symmetry of line segment اللي هو perpendicular bisector للline segment دي ماله بقى؟ هيبقى بيقول لك هيبقى passing through the center. passes through its center. So this axis is also an axis of symmetry of the circle. يعني لو هو perpendicular bisector زي ما حضرتك شايف كده هيبقى passing through the center. وعلى فكرة من ضمن الديفينيشن بتاع الاكس of symmetry للسيركل بيقول لي ان هو any straight يعني axis of symmetry of the circle هو is any straight line passing through the the center of the circle. طيب the tangent of the circle is perpendicular to the radius drawn from the point of tangency. احنا قلنا يعني ايه tangent من شوية لو حد فاكر كنا قلناها.
تمام.
ده كده اسمه tangent صح؟ مماز. ده كده اسمه ايه؟ tangent. فبيقول لك لو انت عندك tangent وعندك radius زي كده ايه اللي بيحصل بقى؟ بيقول لك التانجنت is perpendicular to radius يعني الانجل دي بتكون بكام كده؟ 90 from point of tangency. يعني ايه كلمة point of tangency بالشكل ده؟
تمام.
نقطة
نقطة التمام.
نقطة التماس. طيب تمام كده. يبقى tangent اللي هو tangent يعني ايه؟ اتفقنا تاني يعني ايه كلمة tangent؟
tangent مماس.
مماس. فتangent of to the circle is perpendicular to the radius drawn from the point of tangency يعني يكون perpendicular على الراديوس من الحتة دي. طيب اللي بعديها بيقول لي the two tangent which are drawn from the two end point of diameter are parallel. يعني لو هنا AB is diameter واحنا رسمنا two tangent ادي tangent من عند ال A ورحت راسم كمان tangent من عند ال B مالهم هيكونوا parallel. يعني ايه كلمة parallel بقى؟ اتفقنا من زمان.
وزيان.
ليه هم هيكونوا parallel يا جماعة؟ عشان هو perpendicular من A و perpendicular من B. فطبعا عندك two perpendicular line to one line segment يعني are parallel. يبقى ده two tangent اللي هما الممثلين مرسومين من نهايتي القطر هيكونوا متوازيين. وفي حد بيسأل حاجة ولا النت؟ طيب position of a circle with respect to another circle. position of a circle with respect to another circle اللي هو يعتبر موضع دايرة بالنسبة لدايرة أخرى يعني. معايا كذا تايب كده. the first type يعني between two circles يعني اسمهم distant اللي هو الشكل ده كده. they called distant two distant circles. يعني ايه distant؟ distant زي الشكل اللي قدام حضرتك كده. يعني ايه بالعربي؟ حد عارف يعني ايه بالعربي الشكل ده كده بالعربي لو two circles بعيد عن بعض كده
تباعدتان.
يبقى اسمهم
متباعدتان.
متباعدتان. بالظبط كده. يبقى هم كده اسمهم متباعدتان. في حالة اللي هم متباعدتان هنا بيكون mn greater than r1 plus r2. mn بقى اللي هو الخط اللي واصل بين m و n. يعني لو دي m ودي n يبقى الخط ده كده والخط ده كده اسمه على فكرة اسمه line of centers. line of centers اللي هو خط المركزين. line of centers اللي هو خط المركزين. في الحالة دي يكون mn greater than r1 plus r2. by the way بقى بيكون circle m intersect circle n equals phi. يعني two circles هنا they don't intersect يعني ما بيتقابلوش ابدا. وبرده surface of the circle m intersect surface of the circle n برضه equals phi. وانا كنت فرقت لحضراتكم قبل كده الفرق بين السيركل والسيرفيس لو فاكرين لما كنت راسم سيركلز كده اللي هو لون اصفر وبتاع. طيب نمبر 2 touching externally. touching externally هنا التو سيركلز دول M and N are touching externally. يعني ايه بقى touching externally بالشكل اللي حضرتك شايفه دوت؟
متمستان من الخارج.
متمستين من الخارج صح. بيكون mn equals r1 plus r2 يعني equals the sum of two radii. وفي الحالة دي بيكون circle m intersect circle n equals point، يعني هما لو الاتنين متقابلين هنا في البوينت دي، البوينت دي مثلا سميتها A، فيبقى هما كده بيتقابلوا في ال A. وبرده surface of the circle intersect surface of the circle برضه equals A. وقلنا طبعا surface of the circle اللي هي ايه؟ السطح بتاع الايه؟ الدايرة. اللي بعديها two intersecting circles. الشكل اللي قدام حضرتك دول كده دول اسمهم two intersecting. يعني ايه intersecting بقى؟
متقاطعة.
متقاطعتين. في الحالة دي بيكون mn greater than r1 minus r2 less than r1 plus r2، يعني أكبر من الديفرنس وأقل من السم. وهنا circle m intersect circle n بيكون equals a و b، هما بيتقابلوا في 2 points كده اللي هما اسمهم a و b مثلا، فيبقى هما بيتقابلوا في a و b. طب هو أنا هنا مش كاتب اللي هي surface intersect surface، هنا surface intersect surface يبقى equals ايه؟ اللي هو
تبقى الاريا اللي هي بينهم يعني.
يديني الحتة دي كده، اللي هي الحتة دي. ما تقدرش تحدد تكتب ايه، ممكن تقول عليها shaded part. كلمة shaded part اللي هو الجزء المظلل يعني انت ترسمها وتظلل الجزء ده وتكتب shaded part. shaded part معناها الجزء الايه؟ المظلل. طيب بعديها بيقول لي touching internally. touching internally يعني ايه كده من الكلام؟ يعني ايه touching internally؟ اللي هو الشكل ده.
متمستان من الداخل.
متمستين من الداخل، ولو هما متمثلين من الداخل بيكون mn equals r1 minus r2 يعني equals the difference. وبيكون circle m intersecting circle n equals البوينت اللي هما اتقابلوا فيها اللي هي ايه. اما surface of the circle intersect surface of the circle يديني السيركل الصغيره. يعني لو السيركل الصغيره اسمها circle n يبقى يعني التقاطع بين السطحي الدائرتين بيكون سطح الدائره الصغيره. one inside the other. one inside the other انت قلنا الترجمه بتاعتها كده بالنسبه لحضرتك هتبقى واحده جوه الثانيه، بس هي بتترجم في العربي بنقول بسم الله متداخلتين. متداخلتين هنا لو انا قلت دي سيركل ان ودي سيركل ام يبقى سيركل ان بتكون انسايد سيركل ام، بيكون ام ان less than r1 minus r2 اللي هو اقل من الديفرنس. وبيكون ما فيش عندي انترسكشن بين سيركل ام وسيركل ان، يعني سيركل ام انترسكت سيركل ان equals 5، وسيرفيس اوف ذا سيركل ام انترسكت سيرفيس اوف ذا سيركل ان equals surface of the circle n. طيب اخر حاجه اللي هي اسمها concentric بنقولها متحدة المركز. يعني هي مثلا البوينت دي هي ام وهي ان في نفس الوقت، ماشي، اللي هما الاثنين اترسموا من نفس السنتر، يعني we draw the two circles from the same center. في الحالة دي بيكون ام ان equals 0 لأن أصلا مفيش مسافة بين التو سنترز لأن هما ليهم نفس السنتر بالظبط. وطبعا لو قلت العلاقة من التو سيركلز بيبقى سيركل ام intersect سيركل ان equals phi، والsurface of the circle m intersect surface of the circle m equals surface of the circle n اللي هي بتكون سطح الدايرة الايه الصغير. يبقى concentric معناها متحدة الايه المركز. آخر حاجة هنقولها النهاردة على الحكاية اللي فوق دي بيقول لي the line of centers of two intersecting circles is perpendicular to common chord. intersecting circles حد فاكر يعني ايه intersecting circles؟
دائرتان متقاطعتان.
زي الشكل ده كده، دول كده two intersecting circles. ركز معايا هما كده مثلا يتقابلوا في A و B. خلاص لو انا وصلت A B ده كده A B هنا is called common chord بقى. هو chord كده بس هو اسمه common chord. common chord يعني chord مشترك، وتر مشترك، لان ال A B هنا بيكون chord في سيركل M وchord في سيركل N برضه، عشان كده بسميه common chord. خلاص line of centers قلنا line of centers اللي هو واصل اللي هو MN يعني ده كده اسمه line of centers. فبيقول لي line of centers is perpendicular to common chord يعني تبقى الانجل دي كده ب 90 and bisect it. يعني مثلا لو دي E هيكون EA equals EB، يكون EA equals ايه؟ EB. دي الجزئية دي. طب ايه الجزئية اللي بعديها؟ بيقول لي the circle which passes through vertices of triangle is called circumcircle. الكلمة دي غلط، هي اسمها circumcircle. circumcircle passing through vertices of triangle. يعني لو انا عندي مثلا triangle زي كده وقدرت امشي circle، هتقدر اصلا اي triangle هتقدر تمشي بيه one circle. تمام، one circle. فده A B C. فانا عندي مثلا circle M، قدرت يعني هي بتعدي من الفيرتيز اوف ذا تراينجل، يعني عدت من A ومن B ومن C. في الحالة دي كده اسمها circumcircle. كلمة circumcircle اللي هي الدايرة الخارجة، الدايرة الخارجة للحاجة دي، للشكل، لأي بوليجون. يعني ممكن تبقى circumcircle of triangle of square حسب الحكاية، يبقى دي اسمها circumcircle. طيب هنقف عند هنا، بس في حاجة بقى عايز أقول لحضراتكم عليها، بما إن كده كده المرة الجاية في الأغلب يبقى معانا وقت، لأن إحنا هنبقى قربنا أو المذكرة في الأغلب هتبقى خلصت يعني. في حد من حضراتكم اللي موجود معايا دلوقتي أو حتى اللي مش موجود دلوقتي ويقدر، لو شاف البتاع في التسجيل، لو حد يقدر يحضر حاجة ويشرحها قدامنا المرة الجاية، خاصة الناس المهتمة أو اللي بتعمل ديمو، فإحنا ممكن نساعد بعض في الحكاية دي. اختار أي درس حضرتك أو حضرتك أيا كان عايز تشرحه وتشرحه قدامنا المرة الجاية عن طريق فيديو أو عن طريق PDF، وأنا أفتح لك الشير هنا وممكن تفتحه وتشرح من خلاله. بس الوقت ما يتعداش مثلا 10 دقايق بس كده. ده اقتراح، وخاصة إن إحنا هيبقى معانا وقت المرة الجاية لأن عدد الصفحات اللي فاضل قليل، يعني مش كتير أوي. لو في حد عنده يقدر يقول دلوقتي ماشي، يعني يقدر يقول دلوقتي خلاص انا هجهز حاجه اتس اوكي، ما هتفكروا وبعدين تجربوا ماشي برضه مفيش مشكله. انتوا سمعتوني يا جماعه اصلا ولا لا؟
مع حضرتك.
ايوه تمام حضرتك.
تمام، حد عنده استعداد؟ طيب
إن شاء الله.
يعني
تمام. هو عامه يعني انا مش يعني بس هو اللي ما اشتغلش لغات قبل كده خالص، خاصة يعني اللي ما اشتغلش، وحتى اللي اشتغل برضو لو عايز اي تعليقات، بس اللي ما اشتغلش خالص لو انت تجرأ نفسك بدرس حتى سهل، مش لازم تصعب الدنيا على نفسك، يعني ممكن يبقى درس بس سهل تعمل فيه ديمو صغير كده ونناقش بعض في اللي حضرتك هتعرضه. لو حد عنده اي سؤال
بس
بقى اتفضل.
حضرتك لو هعرضه مثلا خلال الكاميرا أبقى مجهز الورق مثلا كده كتابة بتاعته.
بأي طريقة بقى، الطريقة المناسبة ليك. لو معاك قلم زي اللي معايا ده وتقدر تكتب بيتس اوكي، مش معاك وممكن تحضر بكاميرا، يعني تكتب قدامنا بس الكاميرا بتاعتك تبقى مظبوطة، تبقى متثبتة كويس بحيث ان احنا نبقى شايفين برضو مفيش مشكلة.
بإذن الله.
عندك باوربوينت برضو يبقى تمام جدا، وافتح لك انا الشير وتشيره من خلال تليفونك او من خلال الحاجة اللي انت بتحضر بيها يعني. خلاص،
ماشي سلام.
الطريقة اللي تناسبك يعني، ماشي مش هشرط عليك حاجة.
في سؤال تاني حضرتك، هو التعبير عن المجموعات اللي هو expression of set
مم.
في طريقتين، اللي هو الصفة المميزة والسر.
listing method